Good afternoon, guys. See, today I am going to teach you how to allocate the memory dynamically. If you create a variable int a, then what happens? 4 bytes of memory is allocated inside your system, right? If it is an array, then what happens? If you are creating an array variable, that is int a of I, then what happens? It will create how many bytes of memory? A of 5. Int a of 5, what happens? 20 bytes of memory is created, right? Now our objective is to create those kind of memory in a runtime. So how to do that? Using malloc and calloc function. So we are going to use malloc and calloc function for allocating the memory dynamically. Normally, how you create an array? Int a of 5. So it will allocate 20 bytes of memory. If a user gives only 3 values, then what happens to remaining memory? It is left unused. So to avoid all those problems, so we are going to create an array and we are going to allocate the memory in a runtime. First, let me explain about the memory concepts. See, this is a simple program. Here I created a single variable. If I run this program, then what I get? It is scanning one value and I am storing that value and printing in the screen. Simple program. So I am able to enter the value and that value is stored in a variable a. So what happens inside the memory? So if I use int a, then a small memory space is created and the size of the memory space is 4 bytes, and inside I am going to store any value. This 32767 is the value which I stored inside the variable. What is this 1000? This is the location where my value is stored. And what is that a? That a denotes this or represents this address 1000. Now I am going to show you how to create the memory dynamically. For that I am going to use the function C library function malloc. So the malloc is a function that is used to create the memory during runtime. So what are all the parameters that you require in malloc? So you are going to issue the size malloc, then size. If you give malloc, then if you give the size, then it will automatically create the block of memory and returns what? It will return you void pointer, and you are going to convert that void pointer into int pointer, and you are going to store that starting address in this ptr variable. So this is a standard syntax for that malloc. Then you have to give the size. So the malloc is a function, then you have to give the size, then the return value is void pointer. If the memory is allocated, then it will return void pointer, otherwise it will return null. So we are going to convert that void pointer into integer pointer, and we are going to store the starting address in this ptr pointer variable. What is the use of pointer variable? It is used to store the memory address. So here our malloc function is going to create a block of memory and it is going to return a void pointer, and we are going to convert that void pointer into integer pointer, and we are going to store that in ptr pointer variable. Let me show you one sample program. In this program, first I created one pointer variable, then I have another variable for number. Here I am going to get the number of element directly from the user. So I am going to use the printf statement here, and I am asking the user to enter the number. So now the number is entered by the user. Now I am going to create the memory dynamically. So you know how to create the memory, right, using the malloc function. And what is our parameter? The size of the memory. Here the user types 5, so I need to create a variable to value. So what is the use of size of operator here? The size of operator returns 4 bytes, then the number of element is, if the user enters 5, then 5 into 4, 20. So 20 bytes of memory is created, then the starting address is returned to this ptr. Now whenever I need to store the values, then I am going to use the for loop here, and I am going to store the values here. So ptr plus I. What is the ptr? That is the starting address of our block of memory. Then plus I. What is the use of this plus I? First time it is 0. If it is 0, then what is the ptr? First location. So it represents first location. During the second iteration, if it is I equal to 1, then you are going to store the second value in second location. So now I am going to enter 3 here. That is my number of element. What is the size of array here? 4. How I am getting that 4? That is my starting. What is that 4? The size of the int. And what is this address? The value at position 0. That is our address. Initially, what is the value is stored inside the variable. If you create a variable, then some garbage value is stored inside the variable. See the coding now. See this line, the size of array here is size of ptr. So what is my ptr? ptr is a pointer variable, and what is the size of this pointer variable? That is 4. Why it is 4? Because the size of integer, that is 4. So that is why we are getting 4. Then the value at position 0 of ptr is, what is the use of this operator, dereferencing operator? With the help of dereferencing operator, we are able to get the value that is stored inside the variable. So that is why we are getting some random address. That is our garbage value. So these are all the elements which I typed 1, 2, 3, and for this array I created the memory dynamically. So this is the concept. With the help of this, I am able to create the memory dynamically by getting the value from the user. Now I have another function called calloc. I am going to create the memory dynamically using calloc, but the primary difference between calloc and malloc is calloc is going to store the initial value as 0. But what about our malloc? Malloc is going to give you some garbage values, but calloc is going to store or going to initialize 0 to all the elements. What is the syntax for malloc? Element and size. Sorry, in calloc. In malloc we give only the size. In calloc we give elements comma size. If the user is asking to create 3 memory blocks to store integer variable, then you have to give 3 then comma 4. What is that 4? That is the size of our integer. In what about in malloc? In malloc our syntax is different, so we are directly going to give the number into size of integer. So that will create, if it is 5, then how many bytes is created? If a user is entering 5, then how many bytes is created? 5 into 4, 20 bytes of memory is created. In the same way, if the user is entering 5 here, then if you are giving 4, the same 20 bytes of memory is created here. What is the only difference? Here it initializes 0 to all the elements. Now I will show that with the help of one program. Again, I am having a pointer variable here, int star of ptr, that is capable of storing one address, right? Then int number, again in this program I am going to get the number from the user. Then I have a I for controlling my iteration. Then here I am going to use calloc and check the difference. Here I am directly giving the number, then comma size of int. What about our malloc? In malloc normally we give number into size of int, but here number comma size of int, that is a difference in the syntax. Let's see. First I am going to print the size of the ptr, again that is same, 4. What is our ptr? Ptr is a pointer variable that is capable of storing one address. If we find the size, then what we get? The size of that pointer variable. So we get 4 again. The value at position 0 of ptr is, what is the value we get if you use calloc? Yes, that's right, 0. You get 0. If it is a malloc, you get some garbage value. If it is calloc, then you will get 0. Let's see. Enter number of element. I entered 3, then the size is 4, then the value at position 0 of ptr is 0. If it is a malloc, then some garbage values, but here we are getting 0. Now I entered 3 values, 1, 2, 3. The 1, 2, 3 is stored in the memory location, that is dynamically created using our calloc function. Let me show you the memory representation or how the memory is allocated when you run your program. Assume the user is entered 3 now. The 3 blocks of memory is created inside your memory. The 3 blocks of memory is created now. That means 3 blocks. If a user is entered 3, then 3 blocks of memory to store 3 integer element is created, and the starting address, this 1000 is returned to where? Our which variable? PTR. Now 1000 is stored in our PTR. So whenever we use PTR plus I at the time of getting the input from the user, then what we are indirectly meaning? PTR, what is the value present in the PTR? 1000 plus I, what is the value of our first iteration? 0. So 1000 and our what is our first element? 0. So we are representing here, if we are giving 1000, that means PTR plus 2, then what is the meaning? You are representing which memory location, 1004 or 1008? 1008, that is a memory location. If it is malloc, then what is the value present inside this 1000? Some garbage value. If it is calloc, then 0 is initialized. So what is the maximum value that you can store in one element? 4 bytes. If it is a number, if it is an integer number, then what is the maximum limit? What is the number that is given in your book? 32767. As you said, 32767, but that is not the case for our new system. So what is the 327? Why they are limiting it as 327? 32767, right? Why they are limiting it as 32767? The maximum number of bits that you are able to store in this particular element. At the time of running the program, what is the value I got for integer, the PTR variable? 4, right? Now I will open on calculator. So this is the value that is given in your textbook, 32767. After entering this 32767, check this binary equivalent. How many ones are here? 4, 8, 12, 13, 14, 15. So this 32767 value is true only when your size of the int is 2 bytes. If it is 4 bytes, then this value is not true. Then what is the use of this last bit 0? Your last bit 0, that is used to store the sign. If it is plus, then the sign is set to 1 bit. If it is minus, then the sign is set to another byte. What happens when you give unsigned int? Why you are able to store more numbers when you give unsigned int? At that time, you are able to store the data even for this last bit. So that is why you are able to store more ranges.